Okay, now we're going to move on to the second activity, match equations and tape diagrams. The directions state, here are two tape diagrams, match each equation to one of the tape diagrams. So on the left, I have a tape diagram with two segments. One has a value of 4 and one has a value of x. So I'm just going to stop right here and talk a little bit about using variables, which is what x would be, in numerical expressions. For a lot of students, this causes anxiety because, x is not a number. So what I want to remind you is that all we're doing is using x instead of a question mark. So if it makes you feel better, think about this as being a question mark. So 4 plus some unknown amount has a value of 12. And over on the right, we've got a tape diagram with 4 segments. Each of those segments has a value of x. So each of these segments has an unknown value. But what we need to be clear about is since each of these is represented by the same variable, that means that even though we don't know what amount x represents, each of these segments represents the same amount. X is the same in this for each segment here. We can't have it be 3 in one segment and 7 in another and 8 here and so on. Okay? So, combination of 4 and some number x has a value of 12. And here, 4 groups of some number has a value of 12. And again, we're not solving them. We don't want to know what x equals in each tape diagram. We just want to match each equation to one of the tape diagrams. All right, so our first one, let's call this diagram A, and we're going to call this one diagram B. So our first one, 4 plus x equals 12. So the value 4 combined with the value of x has a value of 12. And this pretty clearly we can see is diagram A. Okay, let's move to number 2. 12 is equal to 4 plus some number x. Well, this is really the same as the equation in number 1. We've just flipped the values on each side. Instead of 4 plus x equals 12, we have 12 equals 4 plus x. So this is represented by diagram A as well. All right, number 3, 12 minus 4 equals x. So this might throw you a little bit because we're looking at combinations. But if we think about this, we're saying 12, and if you remove that 4 from the 12, you're left with x. So this is also could represent the equation 12 minus 4 leaves x. So this is also going to be diagram A. Let's go to number 4. 12 divided by 4 equals x. So again, we're being thrown for a little bit of a loop because I see a combination of 4 of x and I see 4 groups of x, but I don't necessarily see this division. But if I think about it here, I'm taking the value of x and I'm splitting it into 4 equal groups, and each of those groups must then have a value of x. So equation 4 is represented by diagram B. 5, 12 minus x equals 4. This is very similar to the equation in number 3. Here in number 3 I was subtracting 4 from 12 and leaving x. Now I'm subtracting x from 12 and leaving 4. So again, this is diagram A. Equation 6, x is equal to 12 minus 4. And again, this looks like a variation of this. If I have 12 and I take away 4, I'm left with x. This is really just this equation flipped around, right? So this is A. 7, 4 times x equals 12. And again, we can think of this as 4 groups of x equals 12, so that's clearly diagram B. Equation 8 looks just like equation B, but the sides are flipped. 4 groups of x equals 12. And lastly, x plus x plus x plus x equals 12. So we've come to think about diagram B as being a multiplication, representing multiplication or division. But as we said, when we're talking about multiplication, we're talking about repeated addition. So I could also look at diagram B as being x plus x plus x plus x has a value of 12. So this represents diagram B as well.